Hey everyone, and welcome back to another deep dive from Peaceful Rooster Experience. We're going to be talking about stream processing today
Oh, yeah.
and how it's really revolutionizing the way we handle data.
Yeah, it's a big change for sure. We've gone from batch processing, which is
Yeah,
waiting for a letter to arrive
right.
by carrier pigeon to instant gratification.
Yeah, I love that analogy.
It's a whole different world.
It really highlights the difference between, waiting for that carrier pigeon to arrive with yesterday's news.
Exactly.
With batch processing, we used to gather mountains of data and then just process it in one massive chunk overnight.
Right, exactly. But speed is everything now.
Right,
Businesses need to be able to react to events as they happen.
right.
If a retail store only got its sales reports the next day,
Oh, yeah.
they'd be in trouble.
Totally. They'd completely miss out on, adjusting inventory and promotions and all that.
Absolutely.
It'd be like driving a car by only looking in the rearview mirror. And that's where stream processing comes in,
Right.
analyzing data as it flows in.
That's right. It's like having a live GPS
Yeah,
guiding your business decisions.
exactly.
Yeah.
And when we talk about stream processing,
Yeah.
the name that inevitably comes up is Spark Streaming.
Of course.
It's a powerful engine built on top of Apache Spark,
Yeah.
and it's designed to handle this constant influx of data.
It's basically Spark, but with a turbocharger.
Spark with a turbocharger.
Mm.
I love it.
Yeah.
But how does it actually work? I mean, how does it manage to process data in real time without getting totally overwhelmed?
Well, that's where microbatching comes in.
Okay.
Instead of trying to process each individual data point
Yeah.
as it arrives, which would be very resource intensive,
Yeah?
Spark streaming groups the data into tiny little batches.
Okay.
These micro batches.
So instead of sipping data through a straw, it's taking gulps.
Exactly.
I like it.
And these micro batches are then processed in parallel
Ugh.
using the power of Spark. And because each batch is relatively small, the processing can happen really quickly.
Okay, so it's a really clever way to balance the need for speed
Yeah,
with the realities of, processing power.
right.
Microbatching seems like it's the key here, but
It is.
can you explain how that approach actually helps reduce latency?
Sure. So if you had to process every single data point individually,
Right.
you'd be waiting forever for any meaningful insights.
Okay.
But with microbatching, you're processing chunks of data in
Yeah.
parallel.
Mm-hmm.
So the overall processing time is much faster.
Like having multiple chefs working on a meal at the same time,
Exactly.
the food gets to the table much faster.
Precisely.
So by breaking the stream into these bite-sized chunks,
Yeah.
Spark Streaming can keep up with that flow of data and deliver those insights quickly.
Right.
But doesn't that create gaps in the data?
Well, it's important to remember that the intervals between microbatches are usually very small.
Okay.
We're talking milliseconds or seconds here.
Right.
So while there might be a tiny delay,
Yeah.
it's usually insignificant for most real-time applications.
So it's like watching a movie.
Uh-huh.
Even though it's made up of individual frames,
Yeah,
it appears seamless to our eyes because the frames are changing so quickly.
exactly. And microbatching does more than just speed things up.
Okay.
It makes the system more robust and fault-tolerant.
Oh, okay. How so?
Well, if one microbatch fails
Right.
for some reason,
Uh-huh.
it can be recomputed very easily
Okay.
without affecting the entire stream.
It's like having a backup generator
Yes,
that kicks in if the main power goes out.
exactly.
Okay, so microbatching really is like the secret ingredient in this recipe for successful stream process.
It really is.
But I'm curious to learn more about how Spark Streaming actually implements this.
Okay.
What's going on under the hood?
That's where D-streams come in,
Okay.
short for discretized streams.
Okay.
Imagine them as a sequence of RDDs,
Okay.
those resilient distributed data sets, which are the building blocks of Spark.
Right.
Each D-stream is a continuous series of these RDDs,
Okay.
and each RDD represents a microbatch of data.
So it's like taking a continuous stream of data and slicing it into these discrete chunks,
Yes.
each represented by an RDD.
That's right.
But how do we actually work with these D streams? Can we use the same tools and operations that we use with regular RDDs in Spark?
Yes, that's the beauty of it.
Okay.
Spark streaming allows you to leverage the Spark API.
Okay.
You can use all those powerful transformations.
Like map, filter, reduce.
Exactly,
Yep.
just like you would with regular RDDs.
Okay.
The only difference is that these transformations operate on each microbatch individually.
So it's like having a set of tools that work on both static data and streaming data.
Exactly.
That's really powerful.
Yeah.
So if I wanted to filter out all the error messages from a stream of log data,
Yeah.
I could just apply a filter transformation to the D stream, representing that log stream.
Precisely. And that filtering would happen in real time on each incoming microbatch.
Okay, this is starting to click into place.
Okay.
So we've got this framework for handling real-time data with Spark streaming,
Right.
built on this concept of micro-batching and represented by these D streams. But who are the key players in all this?
Well, every orchestra needs a conductor.
Yeah.
And in Spark Streaming, that's the driver program.
Okay.
The driver creates the streaming context, defines the inputs, specifies the transformations, and manages the whole execution.
So the driver program is calling the shots.
Yes.
Setting the stage for our real-time data processing extravaganza.
Exactly.
Who's actually doing the heavy lifting?
That's where the workers and executors come in.
Okay.
Think of the workers like sections of the orchestra,
Yeah.
the strings, the brass, the percussions. And the executors are the individual musicians within each section.
I like it.
The workers are the nodes in our Spark cluster,
Okay.
and each worker runs executors, which are the processes that actually execute the tasks.
So the workers and executors are the ones crunching the numbers, processing those micro batches
Exactly.
across the cluster.
Yes.
It sounds like Spark Streaming has really thought of everything to make real-time data processing both powerful and manageable.
It has.
But there's one thing that keeps nagging at me.
What's that?
What happens when things go wrong?
That's a great question.
Systems crash, networks hiccup.
Yeah.
How does Spark Streaming handle these real-world challenges?
Well, that's an excellent question, and one that we'll dive into in part 2 of our deep dive.
Oh, okay. Looking forward to it.
Welcome back to our deep dive into Spark Streaming.
Yeah, it's great to be back. You know, before the break, we were talking about how Spark Streaming handles those inevitable hiccups.
Right.
You know, the system crashes and the network issues, those gremlins that just love to mess with our data. What safeguards are in place to make sure that we don't lose that valuable information?
Well, Spark Streaming has a robust set of fault tolerance mechanisms to protect our data.
So it's like a tightrope walker with a safety net.
Exactly.
Okay, but how do those safety nets actually work? What are the key strategies that Spark Streaming uses?
Well, one of the primary mechanisms is checkpointing.
Okay.
Spark Streaming periodically takes snapshots of the state of the D streams,
Okay.
including the data that's been processed and the offsets, which are like bookmarks indicating where we left off.
So it's like a rewind button for our data stream.
That's a great way to put it.
If something goes wrong,
Yeah.
we can just reload from the last checkpoint
Right.
and pick up where we left off.
Exactly.
You don't have to reprocess everything from scratch.
Saves a ton of time.
Yeah, huge time saver,
Yeah,
especially when you're dealing with huge amounts of data.
absolutely.
But what about the data that hasn't been checkpointed yet?
Right.
What if a node crashes while a microbatch is being processed?
That's where data replication comes into play.
Data replication. So it's like
Yeah.
having a backup dancer ready to step in
I like that analogy.
if the lead dancer twists an ankle.
Yeah, Spark Streaming can create multiple copies of the data across different nodes in the cluster.
Okay.
So even if one node goes down, we've got those backup copies.
To ensure that the show can go on.
Exactly.
Okay, so checkpointing is like our safety net for our progress.
Right.
And data replication is like our backup copies in case a node goes down.
Yeah. Are there any other safeguards?
Yes, Spark Streaming also uses write-ahead logs.
Right ahead logs.
They act like a meticulous note-taker recording every incoming data point before it even gets processed.
So even if the driver program were to just vanish,
Right.
we'd still have those logs
We would!
to replay the missing data and make sure that nothing gets lost.
Exactly.
So right-ahead logs are like an insurance policy for our data.
Yeah, you could say that.
These fault tolerance mechanisms are really impressive. It seems like Spark Streaming is built to handle anything.
It really is. This robust approach to fault tolerance is one of the main reasons why Spark Streaming is so popular
Makes sense.
for mission-critical, real-time applications. Yeah, it's not just about processing that data quickly.
Yeah.
It's about doing it reliably
Right.
and making sure that we can trust the results.
Exactly.
Speaking of real-world applications, all this talk about microbatches and D-streams has got me thinking,
Uh-huh.
where is Spark Streaming actually being used out there in the wild?
Well, Spark Streaming is being used across a wide range of industries,
Okay,
from finance and e-commerce to healthcare and social media.
so it's kind of like a Swiss Army knife for real-time data analysis.
That's a good way to put it.
Can you give me some specifics? What are some of the most compelling examples?
Well, one area where it's making a huge impact is real-time analytics.
Okay.
Imagine a company that wants to track website traffic,
Yeah.
monitor customer behavior
Uh-huh.
or analyze sales data as it happens.
Okay.
Spark Streaming can ingest data from all sorts of sources,
Like what?
web servers, databases, mobile apps,
Okay.
and process it in real time to provide those up-to-the-second insights.
That's a game changer. Businesses can get a live pulse on their operations.
It is.
Instead of waiting for those daily or weekly reports,
Right.
they can adapt quickly to changing trends
Absolutely.
or customer needs. It's like having a finger on the pulse of your business 24/7.
That's a great way to visualize it.
Another area where Spark Streaming is making a difference is fraud detection.
Oh, yeah, that's a big one.
Think about credit card companies or financial institutions that need to identify suspicious transactions instantly.
Right.
Spark Streaming can analyze all sorts of factors in real time
Yeah, things like transaction patterns, user behavior.
to flag potentially fraudulent activity.
Exactly, before it can do any real damage.
So it's like having a virtual security guard constantly monitoring for any suspicious activity
That's right.
and alerting the authorities before any harm is done.
Precisely.
And this capability can be applied to all kinds of security and risk management scenarios.
Absolutely not just financial fraud.
What other applications come to mind?
Well, the world of finance relies heavily on Spark Streaming.
Okay.
Stockbrokers and traders need real-time data
Right.
to make those split-second decisions.
Yeah, those can make or break a trade.
Exactly. Spark Streaming can ingest massive amounts of market data,
Like what kind of data?
stock prices, trading volumes, news feeds,
Okay.
and analyze it all in real time to identify trends,
Okay.
spot anomalies,
Yeah.
and uncover those trading opportunities.
So it's like having a super-powered financial analyst
Yeah,
constantly crunching numbers and whispering insights into the ears of traders.
that's a good way to think about it.
That's pretty cool.
Yeah.
And it's not just about numbers and money.
No.
Spark Streaming can also be used to analyze human behavior and social trends.
Oh, definitely.
Think about social media companies that need to understand what's trending, what people are talking about, how sentiment is shifting.
Exactly.
So like tracking hashtags, identifying memes,
Yes.
engaging public reaction to the news. Spark Streaming can process that constant stream of posts and likes and shares
Yeah.
to provide insights into those social conversations as they're happening.
Exactly.
This information can be used to personalize content, target advertising,
Huh?
and even identify potential crises or misinformation campaigns.
That's right.
So Spark Streaming is helping us make sense of this ever-growing sea of data.
It really is,
Let's
from
go-
financial markets to social media trends.
Okay, so we talked about that example with the stockbroker
Yeah.
who wants to be alerted to any suspicious price spikes.
Mm-hmm.
Can you walk us through how Spark Streaming would actually detect those anomalies in real time?
Sure. Let's say our stockbroker wants to know immediately if a particular stock price suddenly jumps or drops,
Okay.
which could indicate unusual activity.
Right.
We've got that stream of livestock data flowing into Spark Streaming.
Right.
What's the next step?
How do we actually pinpoint those price anomalies?
We could start by setting a simple rule, a threshold, maybe a 5% change in price within a short time frame, like a minute.
Okay.
Spark Streaming could then apply a transformation,
Okay.
comparing the current price to its previous price
Uh-huh.
and raising a flag if that change exceeds our threshold.
So it's like an automated watchdog constantly monitoring the market
Exactly.
for any suspicious movements
Yeah.
and barking when something seems off.
Precisely.
And the beauty of Spark Streaming is that it's flexible.
It is.
We can define these rules to fit our needs,
Right.
tweaking those thresholds, timeframes, even combining multiple conditions.
Absolutely.
This all sounds incredibly powerful, but is the code behind it complex?
Not necessarily.
Okay.
One of the great things about Spark Streaming is that the code is often surprisingly simple and easy to read.
Okay.
It provides this elegant API that allows us to express complex data logic in a clear way.
So it's not just powerful, it's user-friendly. That's a winning combination.
It is.
There's a code example in the source material that demonstrates how to monitor stock prices and detect those anomalies.
Right, using Python.
Okay, let's take a look at that code snippet.
Okay.
It starts by initializing the Spark context and the streaming context, which sets the stage for our application.
Right.
Then it defines the source of our data.
Uh-huh.
In this case, a socket stream that's simulating that livestock data feed.
Yes. But in a real-world scenario, this could be any source
Okay.
that provides a continuous stream of data.
Like Kafka or Flume.
Exactly.
Okay, next, it defines a function called detect spike.
Right.
This is where the magic happens.
This is where we check if the price change exceeds our threshold,
Right.
and print an alert.
It's like having a custom rule
Exactly.
for identifying specific patterns.
Yes.
And then it applies this function to each microbatch.
Using the for each RDD method.
Okay.
And then it starts the streaming process.
It's like setting our data watchdog loose,
Yes.
ready to bark at any price movements. I really like how this code snippet shows how Spark Streaming makes complex data processing tasks accessible,
It does.
even for those of us who aren't coding wizards.
It really does.
Well, before we dive even deeper into the coding, let's take a step back and focus on those D streams
Okay.
and how they form the backbone of this technology. Welcome back to our deep dive into the world of Spark Streaming. We were starting to peek under the hood to understand how this technology handles real-time data processing.
Right. And I think it's time to dive into the heart of it all.
Okay.
Those D streams we keep mentioning.
And remind me again, what exactly is a D stream?
Sure. So a D stream or discretized stream
Okay.
is a way to represent a continuous flow of data as a series of manageable chunks.
Okay.
Each D stream is a sequence of those RDDs,
Right.
resilient distributed data sets.
The building blocks of Spark.
Exactly. And each RDD in a D stream represents a snapshot of the data stream
Okay.
captured within a specific time window.
So it's like taking a river of data
Yeah.
and dividing it up into a series of buckets.
Right. I like that.
Each bucket representing a snapshot of the river at a certain moment.
That's a great way to think about it. And just like we can analyze the contents of those individual buckets, we can apply powerful transformations to each RDD within a D stream.
So we can use all those familiar Spark transformations,
Yes.
like map, filter, reduce,
Exactly.
to manipulate and analyze those D streams.
That's right.
Just like we would with regular RDDs.
Precisely. The beauty of D streams is that they let us leverage the full power of Spark's distributed computing engine.
Yeah, to tackle these real-time data streams.
Right. It's like having a team of expert data analysts
Wow,
all working on a specific portion of the data streams simultaneously.
that's incredible. Can you give us some concrete examples of how these D streams are used in practice?
Sure. Remember that temperature conversion example we talked about earlier?
Yeah.
Imagine a stream of temperature readings coming in from sensors all in Celsius.
Okay.
We could create a D stream to represent this stream, and then apply a map transformation to convert each reading to Fahrenheit in real time.
So each RDD within that D stream would represent a batch of those Celsius readings.
Yes.
And the map transformation would be operating on each RDD independently,
Exactly.
converting all those readings within that batch to Fahrenheit.
Precisely. And the output would be a new D stream constantly updated with the converted Fahrenheit readings.
Okay, that's a great illustration of how D streams and transformations work together. What other examples come to mind?
Well, let's say a social media company wants to analyze trending topics.
Okay.
They could create a D stream to represent the constant stream of tweets,
Uh-huh.
and then use transformations like FlatMap to extract hashtags from each tweet.
Okay.
Then they could apply a filter to focus on hashtags related to a specific topic,
Okay.
and finally use reduce by key to count the occurrences of each hashtag.
So they could create a dynamic dashboard
Yeah,
showing the top trending hashtags related to a certain event.
exactly, all updated in real time.
That's incredibly powerful for understanding those social conversations.
It is, and the applications go beyond social media.
Okay.
Imagine analyzing website traffic patterns,
Oh.
or monitoring stock prices, or processing sensor data from IoT devices.
You could even personalize recommendations based on real-time user behavior.
Absolutely, all made possible by D streams.
So D streams really are the key to unlocking the power of Spark streaming.
They are, but I have a question.
Okay.
We've been talking about transformations, which operate on those individual RDDs within a D stream.
Right.
What if we want to look at data across multiple batches?
Okay.
Say we want to calculate a moving average or identify trends over time.
How do we do that?
Well, that's an excellent question, and that brings us to windowing operations.
Windowing operations.
Yes. In addition to those transformations, Spark Streaming provides these special operations
Okay.
that let you perform calculations on a sliding window of data across those batches.
So instead of just looking at the data within a single batch,
Right.
we can define a window that encompasses multiple batches
Exactly.
and then perform calculations on the data within that window.
That's right. This is super useful for tasks like calculating those moving averages, identifying trends over a specific time period, or aggregating data over longer durations.
Can you give us an example?
Sure. Let's go back to our stockbroker example. Imagine they want to track the average stock price over the last 5 minutes.
Okay.
We could define a window of 5 minutes
Oh.
and use a windowing operation like reduce by window
Okay.
to calculate the average price of each stock across all the batches within that window.
So windowing operations give us a way to zoom out and analyze trends and patterns that span multiple batches.
Exactly. It's like having a time-lapse view of the data.
Yeah, to see how things are changing over time.
Exactly.
This has been an incredible journey into the world of Spark streaming.
It has.
We explored those fundamental concepts from micro-batching and D-streams to transformations and windowing operations.
And we've seen how this technology is being used to solve real-world problems.
Yes, across so many different industries.
It's helping us make sense of this flood of real-time data.
As the volume and velocity of data continues to increase,
Right.
mastering these tools and techniques will be critical for everyone.
It will. And who knows what incredible applications we'll see in the future.
It's exciting to think about. So keep exploring, keep learning, and keep pushing the boundaries of what's possible with real-time data. This has been a Peaceful Rooster Experience production. Until next time.